Okay, the next example of microbial impacts on our energy resources that we want to discuss is heavy oil. This quote from Head et al. Kind of sums up a lot of what we want to talk about here. Biodegraded oils dominate the world's petroleum inventory, with the largest reserves being found not in the Middle East, but on the flanks of four land basins in the Americas. So basically, what I'm going to talk about here is what are these biodegraded oils? Okay, what are these four land basins? What's the geological setting that has led to accumulation of these large oil reservoirs? Okay, what happens during biodegradation? That's the first question we're going to take on. Well, basically, light oil generated during cooking of organic matter is converted into heavy oil. This change is associated with some compositional changes. It seems that there are some components in petroleum that are more easily or more rapidly degraded by microbes, and this results in a decrease in the abundance of saturated hydrocarbons, and to a lesser extent a decrease in the abundance of aromatic hydrocarbons in petroleum. These changes in composition are associated with some changes in the properties of that petroleum. Specifically, there's an increase in density, an increase in viscosity, becomes less able to flow, and then also a decrease in the ability of oil to dissolve gas. Okay. How widespread are these? Is biodegradation? Well, it seems that more than 50% of Earth's oil occurs as biodegraded oils and tar sand accumulations. The largest known petroleum accumulation in the world is the Orinoco heavy oil belt in Venezuela, which contains about 1,200 billion barrels of oil. The second largest is the Athabasca oil sands in western Canada, which is shown on this slide and contains about 900 billion barrels. Okay, combined with the Peace River and the Cold Lake, together these three reservoirs contain more than 1,700 billion barrels of severely biodegraded heavy oils. Okay, to put these numbers in perspective, the largest oil reservoirs in the Middle East contain less than 200 billion barrels. So these are enormous accumulations of oil, and it happens to be biodegraded oil. Why have these large accumulations formed here, and what is a foreland basin? Why is this good for accumulation of biodegraded oil? This is, in my mind, a really cool example of geology and microbiology coming together and having an impact on human resources in an important way. So let's go to the drawing pad and try to illustrate this geologic setting a little bit better. So the first thing we want to ask is what is a foreland basin? Oops. What is a foreland basin? Okay, basically it's just a basin along the edge of a mountain range. Okay, so that's how we're going to think about it. Basin along, let's say, the margin of a mountain range. Okay, so let me try to illustrate this for you a little bit. We know that mountains are places where you have thick lithosphere, right? Mountains go up, but they also have to have deep roots to support all of that mass, right? And so as they go up, they also kind of sink down a little bit into the asthenosphere, and that downward sinking creates basically a bend in the adjacent lithosphere, right? And that bend right there is a foreland basin right there. Foreland basin. Okay. So now what I'm going to do is I'm going to wipe this clean, and I'm going to just kind of zoom in on this foreland basin and talk a little bit more about it. So I'm going to wipe it clean now. There we go. So There's some thrust faults over here associated with the mountain. Let's do something like that. Okay, and over here we have our foreland basin. So it looks something like this. Okay, and we've accumulated some sediment in that foreland basin as the surrounding highlands have been weathered, and sediment has been transported into this basin, and as the basin has kind of opened up over time. So I'm just going to draw in some beds here. Let's go ahead and give them all. There we go. A little structure. Okay. So there we have a foreland basin that's kind of filled up with sediment. And let's imagine that some of that sediment is rich in organic matter. So we'll draw in a bed of organic matter, rich sediments here. Okay, there we go. Now, as you go down below the surface, temperature increases, right, in response to Earth's thermal gradient. And let's assume that down here it happens to be, oops, let me switch to a pen here. Down here it happens to be warm enough that the organic matter in that organic matter rich layer was cooked and was able to generate oil. Okay, so this is basically an oil kitchen. And you can imagine if this is a relatively long mountain range that this oil kitchen could extend laterally for quite a ways along the edge of this mountain. Okay, and so you could generate a lot of oil there. Now, as a result of hydrodynamic forces, buoyancy, capillary forces, that oil is going to make its way up dip over time, migrating along the basin up towards the margin of the basin. Let's assume that it does that and then ends up getting trapped, trapped in the basin and forms an accumulation right up here because of some structural elements that come together and trap it along the margin of the basin. Well, now up here in this environment, right, we have significantly lower temperature than down there where the oil is being generated. Lower temperature. It's also common to have more fresh water up towards the margin of the basin, lower salinity. Okay, because the circulation of fresh water near the surface would help dilute any salinity that's present. The water would have possibly have a lower residence time, so it would be less water-rock interaction that would occur, less probability that that water would have encountered some evaporite mineral deposits that could be present within the basin. Okay, in any case, both of these things are good for microbial activity, right? They could microbes can thrive in environments that have relatively low temperature and low salinity, and then a bunch of organic matter that could serve as a source of food. Now, because that oil is kind of trapped there and more oil is coming in, over time you can end up accumulating more and more oil there, right? As more oil is coming out of that source kitchen and migrating upward and then being degraded here and forming this low viscosity tar that's clogging up this area. Over time you can accumulate a large amount of petroleum. Okay, and that's exactly what's happened in these large foreland basins. It seems that a lot of this degradation has been occurring and as the result of growth of anaerobic microorganisms with methane as a major byproduct. Because this has occurred over a long period of time and the conditions were just right for it, there's a rather large deposit that's formed. Okay, and so that kind of summarizes some of the main points that I wanted to illustrate regarding heavy oil and its relevance to us now, and especially in the future as these oil reservoirs become increasingly important. Okay, in the next section of this lecture, we'll talk about some of the ways that we could potentially use microbial strategies to enhance oil recovery.